Everyone is using JWT, but is it the best choice? For real world applications, sessions are often better approach. Here is the modern stack. You can use NestJS, Express Sessions, Redis, and TypeORM. User logs in, server create a session, and session is stored in the Redis. I'm not talking about not storing the session somewhere. Browser only gets session ID in the cookies. No token storage in the front end. Every request server validate the session instantly. No problem with the JWT parsing, refresh token, access token, complex logic. Redis makes it stable, scalable. Session can expire automatically. You can destroy session anytime like a real logout. So we are going to use the TypeORM Redis and NestJS and going to implement a session-based authentication end-to-end solution, production ready solution with Redis, TypeORM, NestJS, and Express-based session. Let's get started. Hi everyone and welcome back. So let's start our journey with the second section. So in this section we are going to talk about NestJS session-based authentication with Passport, Redis and TypeORM. So you can see this particular section here. In this what we are going to do is this particular architecture. If you see this, here we have a different components: Redis, Passport, TypeORM. All these sections are we are going to play with them. So this whole section is divided into these things. We will write NestJS because it's NestJS, Passport, Redis, TypeORM. So we are going to just add some controller API routes. We will see how we can use Passport with the Express session, how we will configure TypeORM, how we manage the session middleware, and then once you get a session, because it's all about session based authentication. So you log in, you get a session in the cookies, right? Now you can access any protected API routes. Then how the session can be fetched. So that will be done in two different ways. In first mechanism, we are not going to store any session. In second option, we are going to write a session to the Redis and then we will validate the session. Because let's say you are running a distributed application, right? You have backend running on different instance, and let's say you have a 500 users already logged in, right? And if your application crash or application restart, their session totally gone. They have to forcefully logged out and then log in again, right? To avoid these kind of things, you can also persist the session on some storage. So let's say Redis, we will try to use Redis. So this section is a combination of using TypeORM for managing the data operations, Redis to persist some state like you storing the session ID, Passport which will be used to store the session, initialize the session and manage the session in the NestJS application, and then obviously controller and services, and then we will also use auth guard and this Passport strategies to validate the user login and all these things. So this is a section 2, right? In section 2, if you think what all things are added, here we are talking about how to store the session in Redis, how to work with TypeORM, maybe simple APIs, writing entity, and how you connect to the database. So the first thing we will talk about is how can you set up a platform, because what we need a TypeORM, we need a Redis. So we are going to run all those things using Docker Compose, because we want to run Postgres, we want to run Redis. So it's better, the best possible option for this is write a Docker Compose. So in this video we are going to just prepare our baseline. So we already have just a simple Nest CLI setup. There we will add a Docker Compose file and we will just create a setup so that we can have a Postgres up and running in the Docker container and the Redis up and running. So let's get started. First, we will try to add some dependencies. So here in our project, in our correct project, we will add all these dependencies. So we need to go inside the folder, which is NestJS session based 0. Inside that, we can just install all these dependencies. So you can see that we have all these dependencies added. So first I did a pnpm install at the NestJS session based auth, and then I have added all these 4 different dependencies: NestJS TypeORM, Postgres. These 3 dependencies I need to just work with the database. Then IO Redis, that's just another dependency which I have added. So I will share the project and the whole setup. You can also use an NestJS config. if you want to NestJS config is just a way to extract the runtime environment variables from the process.env. And here we'll start writing Docker Compose. So there is no a fixed way to write Docker Compose file. You can write a plain simple Docker Compose and then Docker Compose override. I will try to divide these both the files into two things, right? One is which contains a very basic information. Then I will also write Docker Compose override file. Okay, so what is the use of Docker Compose override file? And here, because this Docker Compose file is self-sufficient, that means once you do Docker Compose up, I should also be able to bootstrap the database, create a database, so you don't get any permission issues and all. Okay, so this is what we are doing here. This is a tiny script which I have created, and this is the script which can help us to bootstrap the Postgres. So that is all the internals of the Docker Compose. So when Docker Compose creates container, you can also write a bootstrap script, init script, which can create your database, which can create your tables if needed. All those things can be done. I will divide this into two things, Docker Compose and Docker Compose override. In Docker Compose, let's say we'll keep really simple things like just an image. And in Docker Compose override, you can also specify the environments, volume mapping, and all those additional things. Okay, you can see here I have Postgres and this is the volume mapping. I'm using this Docker Compose configuration same across all my microservices because that is self-sufficient. When you do Docker Compose up, this Postgres will spin up with the two database. So we have two different services here, two different containers. You can say one is a Redis and another is a Postgres. So here I will add Redis also in the service. Image is already defined in the Docker Compose. I'm using Docker Compose override to add additional things like environment, volume mapping, port mapping. Same thing I'm doing in the Redis. I just added a port mapping. In the Postgres, image is already defined in Docker Compose file. Here I'm just adding environment, volume, and the port. Okay. So this is my Docker Compose file. I will just do the cleanup and we'll just keep only the things which are required. And I'm putting API database. The important part here is, if you try to see, is the volume. Inside volume, we are passing Docker utils, Docker entry init.d. So this is like a bootstrap or initialization script which will be pushed to the Docker Postgres container that will help us to create databases. Okay, so I have an API database, API testing database. And this Docker utils is a script. You can say it's just a script which is helping us to create two databases or a number of databases based on what you are passing. So here you can see it's creating user and the database. So we don't face any issue with the permissions and all once the database is up and running. Okay, so this is our Docker Compose file. Docker Compose will just keep only image configurations. We'll remove the rest of the additional things. Docker Compose is just a very minimal setup. Docker Compose override you can add to add on additional things. We'll just use Postgres and Redis. Volume we don't need. So this is my final Docker Compose file. And Docker Compose override, you can add more attributes. Or you can say the extended version of Docker Compose file with the more port mapping, volume mapping, and all the other configuration options. So now it's time for Docker Compose up. Everything is there and you can see Docker Compose up. It is pulling up the Redis image because I don't have it. And it has created database. Now it is creating Postgres container. And you can see the script run init script and it has created these two databases. And the username password you already know, API and development pass. These are the two different databases it has created. So next thing is you need to have a Docker desktop. Docker desktop is a simple tool. You can install it on the Mac, Windows, or Ubuntu. Docker desktop help you to visualize the Docker Compose containers. Right here you can see this is the Docker Compose and you can look into the logs also. Here you can see I have two different containers, Redis and the Postgres containers are up and running. And you can also look into the Redis or Postgres through here. So what all we have set up? We have set up a TypeORM, at least the Postgres database, the Redis, and the basic environment setup with the TypeORM and the NestJS config. So now once you have a database and the Redis up and running, what is the next step we need to do? We need to find a way to connect to that database. I mean, you can connect to the Postgres using Express app or simple PG module, but here we are using NestJS. NestJS provide its own way of integrating with the database. So there is a NestJS TypeORM module, and TypeORM we have already installed. So we just need to initialize this module as a root inside a root module, like NestJS TypeORM module, sorry, TypeORM module dot for root async, and pass the runtime configuration. So let's see that how it looks like. This is our containers, and now I have created database folder inside source. Here you can create a TypeORM config and what all configurations options you need. So here it contains multiple things, right? First of all, we can also populate environment which contains the database host, port, username, and database name, right? And your database TypeORM config. So these are the username, password I can copy from my Docker Compose override file. API development pass, and database name is, I think it is API data testing. So now we will write TypeORM config. In TypeORM config, what all things it needs? It needs type, host, port, username, password, and couple of more attributes like database, autoload entity, synchronized true. So these are some of the properties which are NestJS TypeORM configurations. So before we integrate, we need to have all these properties either populated through process.env. I mean, you just put them inside env db host db port username password, right? And they will work. So this is our simple TypeORM config, TypeORM options. Now we can just find a way to integrate with the database. Okay, so here inside our app module, we can just write all the configurations. So here we are not talking about okay how NestJS works and what is the NestJS syntax and all. I mean, we are just using our knowledge which we have with the NestJS modules, controllers, services, how to initialize the TypeORM modules. We are just covering that. So config module I have registered. Now I can just do TypeORM module.for root, right? So this is how you can do the static initialization of TypeORM module. What is static initialization? I mean, when you have everything, you just pass it through the process.env. Or there is a dynamic initialization when you are getting these configurations like database username, password through config module, which is another module of the NestJS. Then it's not a static initialization. It will be called dynamic initialization of a TypeORM module when you are passing those environment variables, I mean those values through the config module. So TypeORM module.for root, and here you can just specify okay app module, domain module. So now let's look more onto the code side, how we are going to add this database module, Redis module, and all those things. So now the next thing is how to connect to the database just through some tool, right? So there is a table plus is actually a tool which can help you to connect to the database. And so you can see all the tables, you can create new tables, you can alter any column, you can look into the database, all the data related operations you can do. Either you install a Postgres admin, PG admin, or you can install just a table plus. You already have a Postgres up and running in the container, and database is also already created, right? So we can just play with the tables which have been created by TypeORM. We can alter the change, or we can perform any kind of changes. So this is all happening through the Docker containers. We just did Docker Compose up, and I can see 2 containers are up and running. You can just inspect them, or if you have database URL, you can just connect to the database, or you can also get inside those containers through this shell. I mean Docker provide these shells so you can access the terminal of those containers. This is my Postgres one, and here you can see the data inside the table. We just need to pass the table username, password, like okay, host is localhost 5433, the host port in the Docker, username API development password, and database is API database, and that's it. Everything is good. You should be able to connect to the database, and then you can perform all these different queries. Hi everyone, so in this video we will talk about database integration. So we already have database up and running, but how can we connect to the database? I mean, if we are not using NestJS, then it is easy, but we are using NestJS, and there is a NestJS TypeORM module provided by NestJS to connect to any database. Let's say MySQL. I mean, TypeORM is actually specific And on TypeORM, you can use type as a Postgres, MySQL, or any relational database. And it provides integration in two different ways. One is a static initialization, where you just pass your credentials like username, password, database, host, and port. Another is a dynamic initialization, where you are going to get the credentials, this information, all the information from the config service, which is environment service, which will help you to fetch all the credentials at runtime. So here we are using TypeORM module.for root. There you just need to pass, okay, type is Postgres, host, port, username, password. Or the other thing is, if you are not fetching them directly from process.env, you have a NestJS config service, then how it works? It works a little different. I mean, there are many ways to register a provider. So here what we are doing is NestJS TypeORM module.for root. Inside imports, you are doing TypeORM module.for root async and passing the config module. And this config module will give us the runtime database URL or username, password, database, all these attributes at runtime through the config service. That's why we are using a dynamic initialization. Let's take a look onto these two together. Now let's see how we are initializing our database connection through these two different approaches. So we have our code. Here we are doing config module.for root. And here we can specify for root, I mean config module is overall global. Then you can write TypeORM module.for root and for root async. These are two different variations we can use. These are two different ways we will talk about: TypeORM module.for root and for root async. I mean, these are the two different ways in which you can integrate with your database connection. I mean, TypeORM module manages it, but TypeORM module need your connection URL, username, password, host, port, all those things. So you can either use TypeORM module.for root, pass all the argument, or you use TypeORM module.for root async and then inject a config module config service and using use factory method. I mean, this is just a way of registering a provider. Use factory, and we are passing config service, and then from config service it can get either you can have just a database URL or just all the parameters like host, port, username, password, all these argument together. This is a simple configuration. Here we are doing TypeORM module.for root async and this config service. So here we are trying to get username, password, host, port, db username, db password, and this is how we can initialize. Now there is another way is you can also try a dynamic initialization of this module. And how this dynamic initialization, it is just a little bit different how we deal with the static. In dynamic we will be using config service. So here we are going to create an external, I mean, independent NestJS module like DB module, which takes care of everything about database. I mean, this is a good approach. You can have a Redis module, database module where you write a database service, database module. You can have a Redis module where you create a Redis pub sub, Redis module, Redis service, right? It's better to create these reusable pieces, and here we are using db module.ts, right? So that's this is the database module, and inside database module we will be initializing TypeORM module.for root async. So here we are planning to just create a database module as a NestJS separate module, so that we can call just database module.for root, right? And you can say it's underneath it is again using TypeORM module.for root async. So I just want to create a reusable database module so that you can use it in every project. So here I'm doing db module, and there is a static method for root. It is returning this for root async. You just pass config module config service, and you just need to write a use factory, right? So how this really looks like, get connection option. So here we are going to call another method, get connection option, that will give you the connection properties to initialize the database connection. So get connection options. Here we are doing config service and database config. Here if you see the configuration is simple. It is returning an object with the type Postgres, database URL, SSL, entities, and synchronize false and logging false. Each and every line has their own specific meaning. The important thing is inside this TypeORM module, either you pass all these as a different argument like type, username, password, host, port, or if you don't like this, then you can just use a URL argument and pass the whole database URL there. So you don't need to have these explicit different variables, which is username, password, host, port, and all. So this is my database URL. I mean, I'm running a Postgres container. So my database URL is Postgres API development path localhost 5433 API database. And I'm passing this argument also SSL. If environment is local and test, then reject unauthorized false, otherwise false. So we are just passing a URL argument. I mean, I modified this method. Earlier we were thinking to pass all, but just combine everything inside a URL. URL contains your Postgres, username, password, host, port, almost everything. Okay. So that is what we are passing here inside dbconfig. Okay. So let's check the code. Okay. So this is my end-to-end build database module, which is a reusable and independent DB module. You can use the DB module .for root async or for root depends on, because this is user defined module, right? On top of that, you can define the static method, let's say for root. So DB module .for root, and here you need to pass an object which contains entities. Okay, that's pretty much simple. This is how we initialize and integrate with the Postgres. And here you can say API database doesn't exist. That means I might not be passing the port correctly. So just fix the port 33 and just try to start the application and npm run start or run dev. And this time it has been connected to the application and application is running. So this is the overall summary, how you can do all these authentication things. So what we have covered? We have covered a TypeORM setup, right? TypeORM with the database. Now we will also talk about Redis. Redis can be a separate module where you can do all the Redis module, Redis service, and then the passport and express session related things. Hi everyone. So in this video, let's work on the Redis. So we have two things, TypeORM, Postgres and Redis. For Postgres, we have used TypeORM. For the Redis, also we are going to write a NestJS module and a service. So what we will do, Redis service.ts, and we will create a Redis module.ts. Okay, we'll write a code. Redis module, we will remove the existing code which uses the Redis client. So Redis module and Redis service. In Redis service, we are going to initialize the Redis connection, right? So inside the Redis module, it is simple. It is going to use a config module to get the Redis host and port. So Redis service will be a very simple setup. It will have a same injectable, and it will be just a simple ES6 class. I mean, it's like a same service as any other service which we have written. So inside this export class, Redis implements on module init, because in this Redis service, we also need to connect to the Redis client. We need to access the Redis client. So there are two different ways. Either you can write some code inside a constructor. So whenever the class gets initialized, it gives you the Redis client instance, or you can use on module init, which provides a method on module init. So using that also you can install this, and we are going to install the Redis module first of all. And inside this we can just write async, just a method which can help us to connect to the Redis. So first of all, on module init, inside this function, we can write a code, helper code, which can help us to connect to the Redis. Or we can also write a constructor. So constructor will give us the config service, and inside this Redis URL we are going to get from the config service. That is important because it's a dynamic. We are going to get a Redis URL from the config service. This dot client equal to create client. Create client is already a part of Redis. Okay, let's fix the typo here. Redis client type. Okay, we got the client instance, and then we can just check on client dot on connect. If there is an error while connecting to the client, we can just log that or await this client.connect. I mean, you can also write this code inside a constructor, but I want to avoid it. On module init is actually a specific way to initialize the service. And this is actually lifecycle method, which can help us to, you want to bootstrap something before instantiating the object of the class, you can do it on module init. And then there is a last method we have is get client. So at runtime, we can also call get client method of this class, this dot client. So we can get this Redis client instance from directly here. Now we need to change the Redis URL. I mean, Redis URL will have a Redis localhost 6379, and we will just introduce a Redis module. If you are trying to add a HTTP or something, obviously it won't work, right? When you do npm run start, it will break. So what you need to do, you need to fix that Redis URL. So here you can see unknown protocol. Yeah. So you need to just change the environment variable to Redis and npm run start. We have added a Redis module in the app module already. You can see domain module and Redis module. So now we can check if we are able to connect to the Redis or not. We are already able to connect to the database, right? So we will just do the check with same check with the Redis. We are able to connect. That is the two things. Second thing we have done, right? Connecting to the database and connecting to the Redis. So this is like our basic foundation setup is done. Now we can start writing the controllers, middlewares, guards, auth service and auth module or user module for that. Okay, so now in this video, let's try to understand the NestJS helper modules to implement authentication, right? So NestJS, I mean, you might have heard about Passport with the Express Node.js, right? So NestJS provides its integration. I mean, it is providing its own module like NestJS Passport, NestJS JWT, which provide a lot of different strategies like local strategy, which helps with the when you are doing authentication with the username password. And that's what we are doing. We are doing a simple session based authentication demo with the NestJS, TypeORM, Passport, Redis, where we are going to allow user to enter the username password. Session created, now use the same session to access any protected routes. So how NestJS can help us? NestJS already has this passport module which provides us all these things. So NestJS Passport provides passport strategies. You need to install all these modules, Passport local or NestJS Passport. And implementing the passport strategies are simple. Here we created a user service, which is just a mock. And this is our auth service, which is just validating the user from the mock data. So you create a auth service, and this is here local strategy. So Passport provide these different strategies. This strategy works just for username password. You enter username password and it will validate for you. Now we also need to understand the actual flow, how all these things are connected. So we have a user module, auth module, and the passport, an express session, right? So we will write a authentication route in the auth module, auth controller. We will write a user sign up inside a user module, user controller, and this passport strategy, passport, auth guard, or serializer will be part of the authentication module. So here you can see we are adding a passport module as a dependency, and then you can write these controller, like simple auth controller for login. If you are able to successfully log in through the local strategy, you can just access the user from the request object. So here we are setting auth guard local. It will be using a local strategy, which is taking username password. So this is the flow which I am talking here. So client will send a login request with the email and a password. It will directly go to the local strategy because we are using passport. Local strategy will validate. It has a validate user method. It takes a username and password. I mean, email is again a username. Don't get confused here. In the passport, by default, it takes username and a password as a 2 argument for the login. So it's username, password. Local strategy again using auth service to validate. Auth service, it will validate everything is good, user is exist, user password is valid. This auth service will return a user, and that user will go to the passport. Passport will initialize, passport will serialize that user and set that user inside a session. Okay, and if you are using the Redis to persist the session, then serialized user will overall we are using express session, and that session will be stored inside a Redis. So this is overall the flow, or you can see all these building blocks, how they are connected. So let's now try to plug and play. So what all things we need here is, so we are going to create a user entity because we need somehow to store some mechanism to store the user attributes, I mean the sign up mechanism. So here in this section, let's talk about user module, user entity, user controller, user service, which will allow us to onboard a user in the database, where user can log in with the user can sign up with the email and a password. Okay, so this is a simple user service we are writing, which is just using TypeORM. Here we are not talking about how TypeORM works, but injectable export class user service. Inside constructor, you inject the repository, private user repository, and then find, just write a helper methods like find by email, create user, update user, delete user, find by id. So because you can also find using find one by email, find one by id, or create will help us to create a user in database, that user repository dot save. And so this is a simple user service we have. Now next thing we are going to do is user module and a user controller. So this is our simple controller, user controller users, export class user controller. Inside this user controller, we will inject the user service, and we will define all the routes like sign up. Sign up is create user. Create user will pass a username and password or email password. So we need to define the DTO. I mean, when you want to pass a body, it's better to create a DTO. So create user DTO we can define inside user.dto.ts, which has 3 arguments: email, password, or role. Okay. First of all, for this, we need to add a class validator. Now, what is the role of class validator? Class validator helps us to validate the request body. So here, install the class validator, so that we will say, okay, email should be of type email, password should be of some constraint you can add, role should not be empty. So just add the class validator, and then you should be able to import the class validator, like all these things. Update the entity. Inside entity, now we will have all these attributes, which are like email, password, or role. So that's our user entity. Inside user entity, now we have ID. ID can be of auto-generated or UUID. That depends on how you define email, password, and role. And so we have just entity and create user DTO. We'll rename it to the user controller.ts, and then we'll also define. So just import the DTO here, and just write a simple code, which is nothing but creating a user by hashing the password. So await this dot user service dot find. Let's find the user with existing email. If it doesn't exist, then that's good. If it already exists, conflict exception. Otherwise, create the hash version of the password. Now also here, if you are using bcrypt, bcrypt has some complication because it's a native library with the C and C++. So always use bcrypt.js. Also, I face the same thing. It's better to just change the bcrypt to the bcrypt.js. So first we are creating the hash version of the password, and then we are just doing user service.create. We already have a create method. Just pass the existing payload, override the password and the role. By default, you can set the role equal to user. Okay, password is a hash password. And once the user is created, return it successfully. And now our simple user module, which contains, okay, inside a user module, just put a TypeORM module.for feature, user service, user controller, and exports user service. A simple user service we have created. Let's add this user module inside our main module, domain module. So another thing is, you also need to pass the entity database module.for root and pass this user entity, so that, because we have set the database module synchronize true. What is this synchronize, false or true? Synchronize false means do not refresh the database on change of the entities. But for development local, we can just set it to true. What it will do is, when you start the application, it will check, okay, you have created entity. Based on that, it will apply the change in the database. All the mod changing, like truncating the columns, renaming the columns, changing the constraint. So this is what it does. You should not use this in the production, because this is not safe, because it directly apply the change in your database by looking at the entities. You should use migrations for that. So here we'll just do npm run start, and it will update the database. It will just create the tables and all the sort of operations it will perform. Some error with the bcrypt. Okay, I need to fix it. Just replace this bcrypt native library to bcrypt.js. Bcrypt.js also provides the same thing, and we will just start the application again. And here we have entity, module, service, and controller. In the domain module, we have registered it. The synchronize is true. So let's start the application again. So these are like let's say if I want to use a new column address, what will happen when you restart the application or start the application? It will alter the database table based on what you are adding inside entity. Logging also we need to make true so that we can also see the logs which are happening in the TypeORM. Otherwise, you won't see the TypeORM logs, whatever the query it is running to update the database table. Let's say I'm just adding some random columns just to show you the logs which are being generated through TypeORM. So you can see here, and the last line, alter table user, add user column username. If you see the last line, so this is running these queries. So this is called, you don't need migrations, you are just syncing the database directly. So this is all we have. We have actually created entities and user controller, user sign up. So we can just now use APIs to create user in our database. Okay, so in the last video, we have created a user controller, user service, user module, user DTO. I mean, just a basic implementation of creating a user in database using TypeORM. And we also set synchronization true in the TypeORM config so that whenever you were changing the entities, the database was getting updated real time whenever you start the application. Now, next thing is let's understand this flow. We need to create a local strategy. Auth service also, because we haven't created auth module, auth service, auth controller that will create, and we will also introduce the passport module, NestJS passport, for initializing the session and saving the session. So first we will create a local strategy. First let's check our sign up. So here I just checked this user sign up API which we have created in the last video, and it works fine. I am able to create a new user in the system. Now let's create a auth module, auth controller, all these passport strategies, guards, serializer. So we need auth controller, auth service, and we can create a auth module, right? Rest we also need to create a strategy, guard, and I think serializer. These are the three things we need. Strategy at least we need. So we will create a auth strategy first, and we are using passport local strategy, which works with a simple implementation where you need a username password for the login, because local strategy will help us to log in. We are not going to write a logic in the user service. Local strategy will take care of adding or validating the username and the password. So I have installed NestJS passport local, these helper modules. And now we will write a simple local strategy, which is injectable class. Inside this, we will just define, okay, export class, local strategy, extend a passport strategy. Be careful with this because I need to deal with the different versions, and different versions are not compatible. Local strategy also, we will just try to refactor it later. But local strategy doing nothing much. It is just adding auth service. And inside this method, we are just going to write a validate. And so what this validate method is doing, auth service dot validate user. It is using auth service. Dependency injected auth service, and auth service is just validating a user based on username and password that will tell us, okay, user is valid or not, user exists in database with the same password or not, right? Now next thing is this local strategy, and then we can create auth service. Auth service is nothing but a simple service. Let's rename the local strategy with auth service, so we don't need to write the whole thing again and again. Auth service, and auth service again I think going to use user service, right? We have two modules, user module, auth module. Auth module is going to use user module, user service. So here we have injected user service inside auth service, and that is just validate user. That means whatever the username password, because auth module doesn't deal with the database. Auth module is dealing with the data, session, these strategies and all. User module deals with the database. So don't need to populate the TypeORM thing everywhere. So user auth module just adding user service. User service already talks to database. So we are fine. You just do find by email. Or find by email, okay, we have a username. That's a string. So if user exists with that email, then we will just use it. So that is just a auth service, which is doing just a validate user. So here we'll fix that username or password. We are just passing the validate user, which is actually validating everything. Auth service. So here it is email and password. So here you might get confused little later. I'm explaining you now. passport local strategy works with a username and password. So you can consider email as a username here. When we inside this validate user, we are calling the auth service. Auth service is again calling user service, which is actually comparing the username and the password. Okay, this is the logic is written here. It is doing all calculations. Now we come back to our auth service. Auth service is doing validate user and comparing the password and all. So first of all, find by email. Okay, user exists with the email, yes. Then let's compare the password. If compare password is same as whatever is stored in database in the hash version, and whatever you are passing, if both are okay, that means the user is valid. That we are doing in a auth service. So I mean, we just divided the responsibility of auth service and user service. Very simple. Now let's check on what we are going to write in the auth controller. So auth controller is another thing. Inside auth controller, we will just try to write a simple authentication API. We are going to use AuthGuard, simple login API, which will just take a username and password. If the authentication works, we will just return the cookies using express session. So this is our simple route. So now here we are using AuthGuard, useGuard AuthGuard, and post login. So whenever you hit a request to this controller, it will directly take you to the local strategy, which is doing nothing but validating the user. It is talking to auth service is talking to user service, and that's it. So this is how we are going to deal with the local strategy. Now let's check this end-to-end implementation in the next video. Hi everyone. So now let's create the user module, auth module. User module we already have. Inside auth module, just add auth service, auth strategy, auth controller, right? In the authentication, we have lots of things, and here TypeORM module.4 feature. If we are accessing the database, I mean, that is just optional. If you are accessing the database, then it's a must that you add a TypeORM module.4 feature. Now we have a auth module. Just import the auth module. So we have user module, auth module, and now we can start playing with this. So here, now important part is, because auth module using user service, so you also need to add a dependency injection of this. Otherwise you are getting error that user service is a provider, not part of auth module. So what you need to do is you need to import the user module inside a auth module, and your error will be gone. Now we'll do npm run start dev, and our application will be started. Yes, it is started. Now we can start playing with this. So there is a auth login endpoint is also created. We have a sign up, we have a login API. This is a user service, user controller, user module. We have a auth module, auth service, auth controller, and we are using bcrypt.js instead of bcrypt. Bcrypt.js is the native library. It won't break or it won't complain. Now we have fixed the bcrypt.js import. Now let's run the application. Okay. So what we are doing is unknown strategy local. So I know what is the error. Reproduce. I will fix it. So what I'm missing is we are not importing all the strategy or everything inside this auth module. And also we need to add a passport module, passport module.register. Then only we should be able to use this passport local strategy session true. And also here inside local strategy, we need to add a local strategy here. That's an injectable service. Right now we can start the application and start playing with this again. So I did a login, unauthorized. Let's see what we are doing here. Unauthorized. I got the reason why it is throwing unauthorized, because the passport local strategy by default works with the username and password. And I'm trying to pass email and password. Obviously that won't work, because default strategy expecting username and password, because the demo based on that. So we need to change it to the username password in the payload. Now username password, and I'm able to log in. This login really works, and I got the request.user, whatever the user is being set. Now next thing is, let's start dealing with the session. So what we want is, once you log in, you should get the cookies. That cookies you can again pass when you are trying to hit the protected API route. So we need to add a express session. Express session is a module which you can just add with the pnpm add express session, and express session, passport, all these three modules: express session, types, and the passport. And connect Redis, I mean, I will talk about this later. Redis we will talk separately, because Redis we are going to use as a persistence layer. So when we want to persist the session to the Redis, then we will be using Redis. Here, for now, here we can just get a Redis service. So this is how you can get the service, injectable service, using app.get. We can get the Redis client using Redis service.get client. Once you got the client, we can use the connect Redis, or we will, for now, we will just simply register the express session. So inside a session, it takes a couple of arguments, and those are really important helper arguments which we pass here. Okay, what will be the expiry of the token, session cookies, how the cookies will be created, are you creating some store to store the cookies, what will be the expiry, how the cookies, I mean, all the parameters which are securing the cookies when you are exchanging the cookies between the client and the server. So this is how your default cookies looks like. You are passing secret which can be a environment variable, reverse, save, initialize cookies, maximum age, and couple of more argument you can add inside the cookies object. And initialize the passport. Here we are doing passport app.use passport.initialize, app.use passport.session. That is another thing. And setting the secret from the environment variable. So now in the next video, let's talk about how this end-to-end works with Redis or without Redis. Okay, so now another thing is, we have done lots of part of it. We have written a strategy. We will write an authentication guard, and we also need a serializer. What is the use of serializer? Because this passport is storing our session. So passport need a serializer or deserializer. When you extract the session, what should be the payload format, and when you put the session, then what should be the format. So we are using serializer and deserializer. So I will write a serializer class that will just have a two methods, serializer and deserializer. Serialize user.ts. So it is just an injectable class, serializer session user. So it has a two methods, serialize user and deserialize user. In deserialize, you can also, once you get the ID, you can also verify it from the user service. Okay, user exists, then done null. So this serializer will be used by passport serializer. When serialize, how to store it, the ID, and when deserialize it, then, because when you deserialize it, you need to extract the whole user object. And when you serialize it, you just need to store the user ID inside a session. So once these things done, we will also write one me route or session route. So once you log in, you will receive a cookies, and save cookies we need to pass to a protected route so that we can access that route without being logged in, because we already logged in, we already have a session. If you don't have a session, we should not be able to access it. So for that, we are writing authentication guard. Authentication guard will just check if you are authenticated or not. So it is simple authentication guard, which is just which is going to just check a request object. If request.isAuthenticated is there, then we are good. So here we will just check returned request.isAuthenticated. It was autocomplete by the TypeScript request.isAuthenticated, and that's it we need to do. So is authenticated, that means this guard now can be added to any protected route. I mean, there are multiple ways to register a guard. You can make it as a global guard, or you can go to the controller route and just say use guard, authentication guard, because I want this guard only on some protected routes I have in system. So here on this me route, I have added authentication guard. Similarly, you can also create another session route and add authentication guard. Authentication guard will be checking, okay, your session exists, then only I allow you to access it. So now it's time to see this end-to-end in the demo with Redis or without Redis. Okay, now let's see all these things together. We have done, so first of all, we will try to play with this without Redis for persisting. And these are the different arguments which we are passing to the cookies, right? HTTP only, secure, same size, maximum age, right? These are really very important to make your cookies secure. For now, we are going to test it from the Postman. So we will make it less secure so we can test it. So secret is actually the key. Based on that, it will create a secret resave. That means whether the session should be saved again or not. Save uninitialized. Can we store the session with undefined? No. And these are the HTTP only true. The cookies cannot be accessed via JavaScript if the HTTP only is true using document.cookies. So it will prevent the accesses attack. secure false. If you want to make secure true, then you can test it only on the HTTPS. I'm making it false for now, so I can test it on the Postman. Same site. The next argument is this same site, so that uh, this allows sending cookies only to the top level navigation like the HTTP post, and not in every HTTP request which are for images, font files and all, right? And strict same site, so only same site can exchange done. And then maximum age, which is all about the expiry. Okay, you should keep the expiry of the cookies minimum as possible so that they cannot be steal and used. Now let's start the application and see this in the live. Using Postman, we are going to hit this. And we have auth login, that's another API. So first of all, we can just do the simple sign up. Sign up means creating the user in the database. So we have post. I am able to create a user. I need to just fix the endpoint. I think it's a users, not user. So I will just remove it. It's users. User already exists. I can create a new user. User 2. Okay, maybe I can create one more. Already all these users exist. So we just pass the unique email and have your users get created. So I have already created a user. Now I will just do the login. Okay, I will do the login with the same. Here we are going to pass username and password, because passport local strategy, and we also got the cookies. So this is important part, because we are doing a session based authentication, and this section is important, how we are extracting the cookies. So we entered a username, password, login, and once the login, in the login response, we are getting the cookies. So this cookie is HTTP only, source is this, and same cookies will be sent because we are using localhost. So when you send another request, the same cookie will be forwarded, right? So let's see that. Now we will just try to use this cookie. I mean, you can actually change it, alter it, whatever you want, just to play around with this. But this is the cookie which we got from the login API. Now the same cookie will be forwarded. So this is the me API. Is authenticated, it is checking. So now to test this, we are going to use two different strategies. First, Redis as a store. So in Express session, we are going to pass store as a Redis, or another is just a plain where we don't have a Redis as a store. It's an in-memory database. So if your server starts, your session will be gone. And let's say you do the login and your server crash, right? Then whatever the session or cookies has been received by the client won't be applicable. I mean, you cannot use that cookies because server has lost that session. You cannot log in it. So to prevent this thing in the distributed environment, we can just use Redis as a store. We can persist our session on the Redis. So these are the two different approaches we are going to play with. So first of all, I will just comment out. Let's play with this Redis thing first. For that, look at this code carefully. What we are doing to pass the Redis as a store. So here we are using Redis store from the connect Redis. I'm passing the Redis client, which I got from the Redis service. First, I got the Redis service instance. Then I got the get client. It gives you the Redis client. And I'm creating this store, Redis store. There are lots of compatibility issues of the connect Redis with the Redis and all. So you need to check my code, which version I'm using. So this store I'm passing. So first of all, we are trying to have a demo of the store, store as a Redis. So in this use case, what we are doing is I do the login. I got the cookies. I can check in the Redis. My session persists there. I restart my application. Try to access any protected APIs. I should be able to log in because my session persisted on the Redis. Okay. Then there is another use case where I'm not using Redis. Then if the server restarts, my session will be gone. I should not be able to access any protected APIs after that. Okay, that is the use case we are talking here. So I'm doing npm run start, and let's see, npm run start dev. I need to go into the correct directory for doing that. And my application started. Now let's see the end-to-end APIs, how we are talking to the APIs and how we are receiving the cookies. So first of all, I will just try to do the login. Simple post. This is my body, test, email and password. And I got the cookies. That's it. Cookies has been created. This is the cookies. Okay. Everything is good. Now I will just try to access my session by just doing get body is empty, and here you can see authenticated true. And here I have added authentication guard on this session endpoint. If you just go to the auth controller, here you can see I have authentication guard, and which is checking are you authenticated? Yes, then you can access it. Now next thing is, so now my session exists. How can I check this session in the Redis? So there is a simple way of doing it. Here you can connect to the Redis, and then you can just query simple commands. So what I did is Redis CLI. You can just get inside the Redis container, access Redis CLI, and hit keys star. That will give you all the keys which are added in the Redis instantly, right? So here you can see session colon. I mean, you cannot get any meaningful output, but your session keys has been created inside Redis. So that is a good sign. That means once I did the login, Redis session has been generated. Now I will restart my application again. Okay, I restarted. My keys still exist. So because Redis is storing this, my keys exist, and I can access the same endpoint again. If you access the same endpoint again, you can still see you're authenticated, right? So this is how the Redis is persisting your session. So in the second attempt, now we are not going to use the Redis at all. Let's see. I will just do a simple login first, get my session. I got my cookies without using Redis as a store, but this session is not persisted. That means that is in the in-memory of the Node.js. Let's say I change it and try to hit it. The me API, let's say I corrupted the session. Can I access it again? I mean, it should send me 403 forbidden, right? That is correct. I mean, this is the expected behavior when you are just updating the keys. So let's clear out the wrong cookies. I do the login again. Cookies are reset again with the correct values. Now I try to access the session, get, and I got the authenticated true. That means I'm logged in. Now what I will do is I will go to the code again. Maybe I'll just restart the application, right? npm run start dev. So I restarted the session. I cleaned up the memory of the server, and now I try to do this. I'm getting forbidden. So this, once I started the server, everything is gone. That gives us clear indication how it works, right? So these are the two different variants I have explained, one with the Redis store, one with the in-memory. And this is how the express-based authentication works. You can also persist it in any persistent form like database, Redis, or anything. But this is how the whole, the flow, TypeORM with the NestJS, TypeORM, Passport, Redis, all these things are paired together. Okay. I hope you like it. In the next session, we are going to talk about the cookies based authentication, and inside the cookies, we will be returning the token, JWT token. So the session based implementation is done. This was like a very basic, and it's not much popular because now we have moved ahead. We are using SSO, OpenIDC, but earlier these were the authentication forms which we were using in our microservices.